Hello and welcome to a new episode of Mostly Engineering, and today we are going to build a solid tool post for our lathe. But before we start, let's cue our new intro. So, long time no video, and I'm really sorry for that, but as I told you, I was in production, and to be honest, if you spend at least 11 hours each day building aircraft and other stuff for the movies, there is no much time to do other projects and the YouTube. So I'm sorry for that, but it will probably happen again. And if you like what you see, please subscribe and push the notification bell so that when the next break occurs and we start the videos afterwards again, that you get notified and don't miss them. And it will also help the channel a lot. So thanks a lot for that, and let's start with the video. Now, as I promised you, today we are going to build a solid tool post for our little lathe, and one that is also able to index our quick change tool holder on discrete angles, so that if we have to change the tool angle, we can do it quick and easy without the need of measurement, at least for some angles. So, why is a solid tool post useful for our little lathe? And a problem that all little lathes have is a lack of rigidity. What this means is that the material can push our tool backwards while it's cutting. And this back and forth between the cutter cutting our material and the material pushing our tool backward causes some vibrations that causes a wavy surface finish, as you probably saw in some of the previous videos. And the compound slab we have at the moment doesn't really help with this, because it's designed to move, and in order to move, the parts have to be a little play. And the rest on top of the compound slab doesn't have enough mass to withstand the pushback by the material. So to get rid of it, we replace it with a solid tool post, what is, like the name implies, a solid piece of metal. And this will greatly help with the rigidity and therefore increase the surface finish of each individual cut. So that's a big advantage. And the second big advantage is that the solid tool post will take up a lot less real estate compared to the compound slide. So we will save some space and have easier access to the different parts of the machine while working on projects. This is huge as well. And then lastly, the indexing feature will help us when we have to set, for example, 15 degrees or 45 degrees. We can just lift the pin and quick and easy set angles. So let's go over to the lathe, take some measurements and start constructing our part. So welcome to the cleaned up lathe, and let's take some measurement for our solid tool post. So the first thing our solid tool post should be able to do is that we can index them. And so we have this hole here to clamp our tool, and then this hole is always free, so I want to drop just a pin in there, and then we can index the tool holder in different angles. So we need to know the radius from the center here to the center here, and this is a thing that is not so easy to measure because you kind of have to eyeball both centers. So what we are going to do is, I already prepared a little wood drill because I have a nice tip. This is the 8mm version and I glued it up. So we are going to drop it in. And then with this tip we will just draw our radius like so. And now when we take it off, we can see the line scribed here, or in your case, because the lamp is too shiny, you can't see it, but I can just take the measurement off, and there we have it, 26. Very nice. So now the other measurements are a little bit easier. And yeah, that's everything we need. So let's go to the computer and draw. So, and here we have the two parts that will make up our solid toolbox. I know two parts aren't as solid as one piece of metal, but the way the thing has to mount to the crosslet and then the quick change tool holder to the parts, that is only going to happen in two parts. And the other reason is that 15 millimeters of aluminium is the thickest stock I have at hand, and the longest cutter that fits in our CNC is 17 millimeters of cutter length, so that's more or less the thickest we can machine. So, but let's talk about the features we have. So on the edges we have the holes for the screws so that we can screw both parts together. Then we have 4 millimeter holes here, so we put some 4 millimeter pins in it. That will help with alignment and also make the whole arrangement a lot more solid. Then on the upper part, what is this one? We have the hole for the M8 thread so that we can screw the quick change tool holder onto it, and here we have 3 millimeter holes in 15-degree increments so that we have the indexing feature for our tool holder. On this side we have here the line for the T-slot and then our hole so that we can align everything to our crosslight. And a lot of this line is missing because one feature we can't do on the CNC is the relief for the screw head on the other side. So after this is done on the CNC, we have to put it manually on our rotary table and cut it out manually on the mill. And in order to clamp it, we need the space over here. And the last feature that isn't relevant for now, but will be necessary when we are going to clamp the way cover to our crosslet, is this little ridge over here, but that's future build to come. So basically, let's go to the manufacturing tab and look at the CNC program. You see lots of operation, and we start with 3 millimeter one fluid cutter that has a cutter length of 9 millimeters, and these cutters are really nice and stable, and we have a lot of them, so that's a safe bet. And we start all drilling all the holes because it's a one fluid cutter. They are also suitable for drilling, and working with aluminium and one fluid cutter is better anyway, because the only one fluid gives up more space for the grippy aluminium chips to clear off. Then we cut the remaining features, so the surface over here, then the screw head reliefs, cut the contours, drilling out all the holes, and cut the contour of the part. And the last part is with a little offset so that we are making room for then our 17 millimeter long cutter. And with the 17 millimeter long cutter, we only cut the outside perimeter of our two parts. The holes we don't cut through on the CNC, because with such a long cutter and such a tiny hole, the risk of breaking the cutter off is relatively high. And this is the last cutter we have, and also more or less the last piece of material we have left. So we have to be careful. And when you break off a cutter in one of these narrow holes, it's relatively likely that a piece of the cutter will remain on the bottom of the hole. And when you try to machine it next, when the new cutter hits this piece of debris, it will break off again. And that's basically the reason why we have only one of these long cutters left. And seeing that this is the only cutter we have left and more or less the only material we have left, we can't allow for this risk. And what we are going to do is, when the parts are finished, we put all these holes in the mill and drilling them manually all the way through. So that's basically the plan. So let's go over to the CNC. I machine it and then see you with the finished parts. So, and here we have our CNC parts. Came out really nicely. The CNC part went all well. We didn't broke off our long cutter. So really nice. But unfortunately not everything worked out perfectly, like you can see here. I broke off one of the drill bits while drilling through the holes, and as you can see, it broke off in a manner that it was impossible to remove. But luckily it's this hole and not this, for example, so I think we can live with the fact that we only have 3 screws to screw the 2 pieces together. But the important question now is, how does it fit? And there's only one way to find out. So let's put it on here, push it down, and yeah, this thing is rock solid. So really nicely, and maybe a bit too solid. Holy fuck. Yeah, maybe I just go over the file 1 or 2 sweeps so that it's not as tight as at the moment. Yeah, and then we cut the relief for the screw head over here. So, and here we have everything set up. We have the rotating table on our mill, and then there's a part chucked on as a little ring, and at the moment the spindle is still aligned with the center of our hole, and then we can push it to X on the X-axis to cut our relief for the screw hole. So let's get started. So, and let's do the indexing pin. So we have an 8mm piece of brass, and first we will, come on, clean up this edge over here. So that looks nicely now, and first thing working with the solid tool post now is when the edge is still rough, so that the tool is going in and out of the material as it rotates along, you really feel now the vibrations of this cut in the wheel. So like it goes directly from the tool into the tool post into the wheel. There's no wiggle room left in here. So yeah, that's exactly what we want. A lot of rigidity over here. Anyway, now we have to turn on a 3mm pin so that it gets in the indexing hole, and we have to do it 4mm deep. So that's this side of the aligning pin done, and now on the other side we will make a nice surface and cut a thread so that we can put a nice handle on it. So, and we are done. We have the finished indexing pin in our solid tool post, and so we got in, wiggle a bit, and now we have the 90-degree angle, and if we want to change the angle, we just lift it, put the angle in, and now we have 15 degrees, or wiggle it, and now we have 45 degrees, and so on and so forth. So let's put it tight on 90 degrees. So, and that's our indexing solid tool post. Very nice. And what I already noticed while machining this indexing pin is that the tool is much more solid. Now, when you move the handle over here, you really feel what the tool is doing. And by doing the clean passes on the end, I noticed that I don't really remove any material anymore. So what tells me that the vibrations while cutting are way lower than before. So yeah, really nice. And now I will live with it for a while and see how it works. And if it works fine, if I don't find any improvements to be made, I will at some point order these parts in tool style to make it even more solid. And if you want one, please let me know, because if I order it and I order more than one, it gets cheaper for all of us. So that's it for this video. As always, if you have questions, comments, let them down below and I try to answer them as quickly and correctly as possible. And all that's left to say now is thanks for watching and see you at the next time. Bye bye.